Hello friends, this is Gangadhar from Maths Kingdom. This is another question asked in Advanced 2019 in paper 2 for more than one answer type question in section 1. And the question is from the house of matrices and determinants. It involves with the properties of determinants as well as it involves with the solving the homogeneous equations. See, the question is very simple one. Usually many say it as a lengthy problem, but I will say it as a tricky problem. See, if you use your logic, if you use the logic, then we can easily solve this problem. See, first of all, let us go through the question. The question is given like this. The question itself, two matrices P and Q are given, and since the matrix P is of triangular matrix, these three terms are zeros. So this is somewhat comfortable in calculating the determinant as well as in calculating the products as well as in calculating the inverse also, because some of the elements are zeros, right? So these are the two given matrices P and Q. And then another matrix R is defined like this, like PQ P inverse. R is PQ P inverse. Then we need to check which of the following options are correct. See, the options are like this, right? See, first of all, I am going to check option 2 and 3. Then I will check option 1 and 4. Because option 1 and 4 involves with the solving of homogeneous equations. Option 2 and 3 involves with the usual multiplication along with the determinant, right? See, first of all, coming to option 3. What is option 3? Here, option 3 is determinant of R is the determinant of this matrix plus 8 for all x belongs to R. Without depending on the value of x, this determinant plus 8 will give us the determinant of R. So for that, initially we need to know the determinant of R. So, but what is actually R? R is PQ P inverse. So then what is the determinant of R? Determinant of R is determinant of PQ P inverse. So usually we will come across so many problems in our regular materials related to this PQ P inverse. So determinant of R is the determinant of PQ P inverse, and I can write it like determinant of P into determinant of Q into determinant of P inverse, and this is determinant of P, determinant of Q, and 1 by determinant of P. These two get cancelled and I left with the determinant of Q. But what is determinant of Q? See, this Q is this matrix. So to calculate the determinant of Q, I can move with any row or with any column. So I am moving with the second row because two elements are zeros. We know that the determinant of a matrix is nothing but the what? Sum of the products of the elements when multiplied with its corresponding cofactors, okay, along with the signs also. See, this is plus, minus, plus, minus, plus. So 4 into, leave this row and column, okay. Then what it is? Determinant of Q is nothing but 4 into determinant of, okay, I have to leave these two. Then 2, 6, no, this is 2x, 2x and then x6. This is the determinant of matrix. Then this is nothing but 6 to 6 12 minus x squared. When you multiply with 4, 48, 12 4 is 48 minus 4x squared is the determinant of R. So I have determinant of R as 48 minus 4x squared. Now, see, if you come in here, we need to calculate the determinant of this one. See, again, if you observe, for this problem also, these two elements are zeros. So directly we can calculate this determinant. So what is this determinant? This determinant is 4 times of 2x, x 5. Instead of 6, here we have 5. So that is nothing but 4 into 2x, x 5. So this determinant is nothing but matrix which is given is 4 into 2x, x 5, which is nothing but 4 into 10 minus x square, and that is nothing but 40 minus x square. Determinant of this is 40 minus x square. If you add 8 for this, it will again become like 48 minus x square. So if you observe finally, determinant of R is 48 minus 4x square, and in the same manner determinant of this matrix when you add 8 again gives us 48 minus x square. So if x is any real value, these two are equal. So without involving with depending on x, the determinant of r as well as the right side value is same. So option 3 is one of our correct choice, is the correct one, right? So this is directly from the determinants, and the calculation is also not lengthy, I think, right? Then coming to the second option. Now I am going to check second option. What is the second option? There exists a real x such that PQ is equals to QP. See, product of these two is equals to product of Q and P, and there exists a real x, whether x is possible or not. See, when you multiply P and Q and P, if they are equal, after equalizing the corresponding terms, corresponding values, I need to calculate the value of x. If there exists x, this is our choice. If there is no such x, then this is not a correct choice. See, P into Q is equals to Q into P. This is P and that is Q. P into Q can be written as 1, 1, 1, 0, 2, 2, 0, 0, 3. This is P. 1 multiplied with Q is 2, x, x, 0, 4, 0, x, x, 6. Okay, this PQ is equals to QP. So what is Q here? 2xx 0, 4, 0, x, x, 6 is Q, and we need to multiply it with P, 1, 1, 1, 0, 2, 2, 0, 0, 3. These two are not actually equal because matrices are not commutative. So, but sometimes depending on the matrices, they may commute, like PQ is equals to QP. Okay, so for that, if there is any x or not, we need to check. See, usually after multiplication, after calculating all the elements of the resultant matrix, we have to equalize. But what I am going to do is, without calculating all the elements, just I am concentrating one element. See, the product is again a 3 by 3 matrix. This product is also again a 3 by 3 matrix. After calculating all the elements of the resultant matrix, I need to equalize the corresponding elements. So first of all, I am going to concentrate on this place. Okay, I will calculate this place and I will equalize if, and then I will try to calculate the value of x. What is this place? This place is first row, second column. So how can you get? By multiplying first row with the second column. See, the first row is 1, 1, 1 and the second column is x, 4x. If you multiply correspondingly x plus 4 and plus x, so this element is actually 4 plus 2x from the left hand side. And from the right hand side, again we need to multiply first row with the second column. And if you multiply, 2 into 1 is 2, 2 into x is 2x, x into 0 is 0, and this element is 2 plus 2x. And if you try to equalize these two, this element is 4 plus 2x, its corresponding element is 2 plus 2x. So 4 plus 2x is equals to 2 plus 2x, can't have any solution. We can't fix any value of x for that to equalize that 4 plus 2x is equals to 2 plus 2x. So there exists no x such that PQ is equals to QP. But it is mentioned that there exists a real x. Okay, so but we can't find the x, so this is not a correct choice, this is the wrong one. So since PQ is equals to QP, without calculating the total product P into Q and Q into P, directly we are mentioning that there is no x, right? This is the second option. And after that second option and the third option, I need to check first option and then fourth option. These two are also tricky questions, but these two are depending on the concept of system of homogeneous equations. Okay, right. Before going to check these two, I am going to give certain idea about the system of homogeneous equations. And before that, I suggest you all to follow and watch all the videos related to these advanced and the mains previous year questions in our channel. Okay, to get in touch with the continuous practice. Okay, so daily one problem of previously asked question will push you towards your success. So daily practice at least one problem of previously asked questions, and that too through our channel. Okay, and don't forget to subscribe for the channel, and please share it for the needy and the interested people, right? Then before going to first and fourth options, what is about a system of homogeneous equations? System of homogeneous equations means if Ax is equals to 0 and this A is a 3 by 3 matrix, whereas this X is a 3 by 1 matrix and this is equals to a 0 matrix of 3 by 1 order. Whenever this system has solutions, see, if you see this is A, if the determinant of this A is not equals to 0, then surely the solution of this system of homogeneous equations is 0, 0, 0. And if the determinant of A is equals to 0, then the solution of this matrix X is some x, y, z. And if the determinant of A is 0, then we will have a relation between x, y and z. We will have a relation between x, y and z. In this case, we will get infinite solutions. We have a ratio between x, y and z from this case. With this ratio, we can calculate, we can assume different values, infinite solutions for this matrix X. Okay, so this is usually these are the system of homogeneous equations. We need to solve the system to calculate variable matrix X. And what I am saying here is, if the determinant of this coefficient matrix is not equals to 0, then there is only one solution, that too a trivial solution. All the variables are zeros. And if the determinant is equals to 0, then that X variable matrix will have infinite solutions. And usually we will get a relation between x, y and z, that to a ratio between x, y and z. Depending on that, we will calculate infinite solutions. Based on this concept, I am going to check option 1 as well as option 4. See, option 1, it is given that, see, this is R into alpha beta gamma, that is equals to 0, 0, 0. Right, what we need to check? There exists a unit matrix. So for that, first of all, this is of the format AX. This R is a 3 by 3 matrix because R is PQP inverse. So for that, I am going to observe the determinant of R. But actually, for option 3, we already calculated determinant of R as 48 minus 4x square. Right? See, here they mentioned that x is equals to 1. If x is equals to 1, okay, this matrix, this determinant is not equals to 0. Since this determinant is not equals to 0, okay, for x is equals to 1, there exists a unit vector for which R alpha beta gamma is equals to 0. Right? Right. Since the determinant is not equals to 0, then as per our logic, this alpha beta gamma surely equals to 0, 0, 0. Since this is not equals to 0. So if alpha beta gamma are equals to 0, then for this vector, these alpha beta gamma are zeros, then its modulus is not as unit 1, so it is not a unit vector. See, this is not a unit vector if the determinant of R is not equals to 0. So we have that determinant of R not equals to 0, so this is not a unit vector. So for this is a wrong option, right? Then we need to check option 4. For option 4 also, I am going to use the same concept. See, what is option 4 here? See, option 4 is given like this: R 1AB of 6 1AB. I will rewrite it like this: R minus 6I of 1AB is equals to a 0 matrix. Now if you look, again it is of the format AX is equals to 0. For that I need to check the determinant of this R minus 6I. So what is the determinant of R minus 6I? So what is R? Actually it is PQ, P inverse minus 6. I will write this I as PP inverse. Then it can be written as determinant of P, Q, P inverse minus 6P, P inverse, and I will write it as P6, P inverse. Okay, and we will write it like this: determinant of P of Q minus 6I of P inverse. From this, determinant of P into determinant of Q minus 6I into 1 by determinant of P, these two will get cancelled, and the determinant of R minus 6I is equals to determinant of Q minus 6I. Determinant of R minus 6I is nothing but determinant of Q minus 6I. So actually we don't have R here. To make R, we need to multiply P along with Q and along with P inverse. But To avoid that lengthy work, what I am going to do is, I will calculate the determinant of r minus 6i. That determinant of r minus 6i is directly equals to the determinant of q minus 6i. So, but what is the determinant of q minus 6i? So, this is q actually, and in the question itself they mentioned that for x is equals to 0. So, we need to replace that q with 0 and then we need to calculate q minus 6i. So, first of all, you just keep in mind that this determinant of r minus 6i is equals to determinant of q minus 6i. For space, I am erasing this. This is r minus 6i and this is equals to determinant of q minus 6i, and that is equals to determinant of q minus 6i. Q is this one, and if x is 0, I will write it like this: 2, 0, 0, 0, 4, 0, 0, 0, 6. This is actually q and minus 6i. Minus 6i means we need to subtract 6 from the diagonal elements. If you subtract 6 from the diagonal elements, this is 2 minus 6, this is 4 minus 6, this is 6 minus 6. 6 minus 6 is again 0. That means this row becomes 0. So directly the determinant is 0. So the determinant of r minus 6i is 0. Right? See, if you see, this is the system of homogeneous equations. Since the determinant of r minus 6i is 0, then there exists infinite number of chances, infinite number of solutions for this variable matrix 1ab. But actually, usually we have 3 variables, but here they mention that one variable as 1. So, with the logic of system of homogeneous equations, if you solve this, directly we will get a relation between a and b. Since we have a relation between a and b, that to a ratio between a and b, also they mention here that a plus b is equals to 5. This is one relation between a and b, and this is one relation between a and b. By solving these two relations on a and b involving the two variables a, b, we will get the values of a as well as value of b. That in the sense, this is a correct statement. Since we have a ratio between a and b, surely we will fix a such that a plus b is equals to 5, and to satisfy that ratio between a and b. Right? So this is a correct choice. To say this as a correct choice, what I did, by avoiding the lengthy calculation, I calculated the determinant of r minus 6i, and that is directly 0. Since the determinant is 0, we will have infinite solutions in this case. Infinite solutions in the sense, we will have a relation between a and b. From this we have a relation between a and b. Here we have a relation between a and b. Solving these two, we will get the values of a and b. So, this is a correct choice. So, finally, for this problem, the correct options are 3 as well as 4, and the wrong options are 1 and 2. So, if you go with the logic, the problem is again a simple problem asked in advanced 2019. Thank you.